Hello everyone, this is Guan-Ting and Manuel Juangbi, and our topic is Multilingual WSD, a framework for multilingual word sense disambiguation leveraging knowledge-based systems. So our main goal is to establish a framework that can leverage knowledge-based systems and pre-trained language model to solve the multilingual WSD task. Also, we want to improve the previous works using data augmentation and post-tag prediction, and investigate the potential in multilingual case. So here is our related works. Those are the very latest works in WSD task. So the first part is to use pre-trained language model with context close pair, like WSD and bioencoder model. By using GLOS, that is the definition, they achieve very good performance on WSD's task. The second part is automatically generating multilingual WSD dataset. Because it is hard and costly to get multilingual WSD dataset, so they want to generate multilingual dataset automatically, like the word train-o-matic and one-sec, and they also get a very good performance on multilingual dataset. We want to bridge the gap between those related work, so we propose this multilingual WSD model. First, we replace BERT with multilingual BERT, and also the sentence close pair will not only be in English. The COS token is used for downstream tasks like classification or regression. In training stage, we will query our target words into a knowledge-based system like WordNet or BabelNet to find candidates of senses. So we will label the correct sense to 1 and label the wrong sense to zeros. By doing so, we can generate the sentence close pair data with labels. In testing stage, we do the same thing as training stage to find candidates of senses. And then we will input those sentence close pair into multilingual BERT model. Eventually, we can choose the possible word sense with highest probability.
Next, we want to augment our training data using several techniques, and we want to integrate post-tag prediction into our framework. Once we've done that, we're going to take our best monolingual WSD model and evaluate it on 5 different languages that have not been seen during training phase. Lastly, we're going to use some automatically generated multilingual training corpora and see if using them is going to improve performance. The goal for augmentation is to obtain several examples for each sense. With back translation, we're going to take a gloss, translate it into a different language, and then translate it back into English, hoping that we're going to obtain a different wording for the same gloss. Then we're going to add glosses for our word senses hyponym and hypernym. And lastly, we're going to leverage the fact that BabelNet contain multiple glosses for certain senses. There are 2 ways in which we can integrate post-tag prediction into our model. The first one is to use a pre-trained model, for example, FLAIR embeddings model, which has a very high accuracy, and use the prediction to filter out the list of candidate senses we obtain from our model. Another method is to label the data so that if sense and post-tag are both correct, the label is 1. If both sense and post-tag are wrong, the label is 0. And if the sense is wrong but the post-tag is correct, the label is between 1 and 0 with a parameter that we will have to fine-tune. As of now, we managed to reproduce WSD and we obtained a F1 score of around 0.7. The problem with this model is that it's not as good as compared to a newer model called bioencoder. So the question now is whether we want to switch to bioencoder model. On one side, the performance is going to be better, but on the other hand, it's going to take longer to train, since we have to train 2 separate BERT models. We've also started creating a multilingual sense annotated dataset using BubbleNet. But this is proving to be very lengthy because we have a limit of 1,000 API calls per day.